you can take out your highlighter and highlight the definition of what a trig identity is. A trig identity is a statement that has trig ratios and is always true. In fact, from chapter 6, we have some of these already. We already know a couple of them. Some of them were definitions, and some of them we figured out from our big ideas. So first of all, from chapter 6, we're going to look at some identities that we call definitions in chapter 6. These are reciprocal identities. Cosecant is equal to 1 over sine. You could also write sine of theta is equal to 1 over cosecant theta. Secant theta is 1 over cos. We could also write cos of theta is 1 over secant theta. And cotangent is 1 over tan, so we could also write that tangent is 1 over cotangent. So these were definitions in chapter 6, and now since they're trig equations that are always true, they are called trig identities. From chapter 6, you had the big idea that tan of theta was sine of theta over cos of theta, which means that cotangent of theta is cos of theta over sine of theta. And the other one that we already know from chapter 6 is this one. What's this always equal to? 1. That makes it an identity as well. So what's going to happen is you're going to be allowed to use these definition identities, and then there's going to be a few more that we develop that get on your formula sheet, and we solve something called a proof. So today, I'm going to introduce you to proofs, and I gave you a handout, and we're going to do all of these proofs on loosely. Okay, so we'll start with question number 5. And the way that a proof works, it has some very particular aspects to it. So on your loose leaf, first of all, you're going to rewrite the question. Cos t secant t equals 1. You're going to write out the question, and the very first formal thing for a proof is that if you want to prove something is true, you can never say it's true until you've proved it. So the first thing we do to make sure we don't ever put an equal sign again is draw a line at the equal sign, separating our left side and our right side. So you are never, it's like a wall, right? You're never allowed to move something over that wall. The 1 stays on this side. And it becomes a puzzle. Our goal in this puzzle is to manipulate the sides until they match up perfectly. And as far as manipulating, the only things you are allowed to use so far are our definitions of our reciprocals, our quotient identities, that tan of theta is sine of theta over cos of theta, or cotangent theta is cos of theta over sine of theta. And we also have that sine squared theta plus cos squared theta is equal to 1. These are the tools that we can use to manipulate. So what it means is, if you see a cos t, you could change it if you had a rule that says you could change it to something. Oh, I could change it to 1 over secant. I could change the secant t if I have a rule or an identity already that says you have something that secant theta is equal to. We do. Secant theta is 1 over cos theta. And one of the things, our first observation, is that no matter which of the 6 trig functions you have, they all have something in common they can change to. They can all either be written with a sine theta or a cos theta. So for example, we go through all 6 of them, starting with, well, obviously sine and cos, if those are 1 and 2, you don't have to change them. They're already sine theta and cos theta. But if I go to cosecant, does it make sense that I can change cosecant to 1 over sine? I can change secant to 1 over cos. Cotangent, I have 2 choices. But if I use this one, it changes to cos and sine. And tangent, I have 2 choices. I can change it to 1 over cotangent, or I can change it to sine theta over cos theta. So this means every single trig function, if you want to, you could change to sine theta or cos theta. This is going to be a good strategy, because if we can take both sides and change things to only sine theta and cos theta, chances are that they'll match up increases. So in this first example that we're doing together, and keeping in mind that strategy, I would say, okay, let's try to change things to just sine theta and cos theta. I would keep my cos theta or my cos t the same, but instead of secant t, I could rewrite that as 1 over cos t. And I get into fraction work. Technically, this is a fraction times a fraction. Can I simplify anything? Absolutely. Do you see that the cos t's would simplify? That I could simplify this cos t with this cos t, which would leave me with just 1. And now our proof has been completed, because our goal was to get the left side and the right side to be identical. This one was really easy. We just had to do one change. Things simplified nicely. Other formalities in a proof. It asks you to prove it. You get the left side and the right side the same. Then you have to make a statement that says you noticed they were the same. So we write, therefore, the left side equals the right side. Just a little statement saying that you have completed the proof. Then I always add something that often comes at the end of mathematical proofs. The following abbreviation, QED, and I like to follow it up with a little, I always like to put a little box in it. It's personal stuff. You don't have to have that little box. You can have your own little symbol, but at the end of mathematical proofs, this is often written. It's actually an abbreviation for Latin that says, what you asked me to show, I have shown. Or quod erat demonstratum. What was asked for has been demonstrated. Oh, you proved it. And like a big period at the end, I don't know what that box really is. It's like, this is the end of my proof. So if you like to add that little formality, perfect. But you do need to say that the left side equals the right side once you've got it proven. So this one, relatively straightforward. We'll do a couple of other ones. Let's do number 12 together next. I'll leave questions 6 to 11. You can work on those. But number 12. So again, formality, we rewrite the question, prove. And sometimes the exam is really nice. Secant theta over cosecant theta equals 10. Sometimes the exam is really nice. They actually draw the line for you. Because if you put an equal sign in a proof before you've proven it, it's an automatic 1-mark deduction, which is really harsh. So drawing that line is to force you to say, this is a wall. I can't move things from one side to the other. I can only work on both sides. And often, if you try to figure out the whole proof in your head, often that won't work. We're going to develop some strategies. So far, I've only given you one strategy. And that one strategy is, if you want to, you can change everything to sine theta and cos theta. So if I did that in this situation, can you say that you could change the secant theta to 1 over cos theta? And you can change the cosecant theta to 1 over sine theta. Something you'll notice that I try to do is, this is my main fraction line. Sometimes I make it really long, sometimes I make it thicker. Because you can get lost when you write things, and I would say use lots of space. You want to save paper? Don't. I'll give you loose leaf. I'll give you scrap paper. I'll give you whatever you need for paper. Use space. So like in between, I have like extra space here so that my fractions don't start to get combined into other things. It's easy to lose focus and lose where you are. So I changed that to sine and cos. Can you see I can also, on the right-hand side, I could change tangent to sine and cos. So main strategy, change things to sine theta and cos theta. Then, right where we started with today, we have to write both sides as a single fraction in lowest terms. And most of the time, not always, but 90 to 95% of the time, it will work perfectly for you. Do you see on the left side, you don't have a single fraction. You have a fraction divided by a fraction. What do we do when we're dividing fractions? Multiply by the reciprocal. So I'll rewrite the 1 over cos theta. And I'll multiply by the reciprocal, which is sine theta over 1. Can I cancel anything? No. I can't cancel out the thetas because they're part of cos and part of sine. Tempting to do so, but not allowed. Right? They're not exactly the same, so the best I can do is multiply the tops. 1 times sine theta is sine theta. 1 times cos theta is cos theta. And so now I've got a single fraction on the left-hand side, and it is exactly the same as the right-hand side. As soon as they're exactly the same, your left side is equal to your right side. I know there's something fulfilling about the proof, so I take extra time at the end. Do that QED. Feels kind of good. Okay? So they're like puzzles. You have to change things, manipulate things, get single fractions. Can you get them to match? Can you do algebra to get them to match? Warning. If you make up algebra so that they match, it's usually a 2-mark mistake. It's a 1-mark mistake for making up the algebra, and usually if you have to make something up, it means you made a mistake earlier and they're no longer matching. So if you try to undo an earlier mistake by making another mistake, it'll usually cost you 2 marks. So we want to make sure we're careful and we're only following our fraction rules all the way through. Here, let's do one more, a little bit more difficult. Let's do, what looks more difficult to you? When you look at 14 and 15, which one looks scarier to you?
14?
It's a secant U on the bottom there. Should we do 14? Do 15? Okay. Okay. Prove 1 plus sine z minus sine z equals 1 over secant squared. I'm going to just bend that line so there's a little bit of room to work on both sides. Okay. Changing things to sine and cosine. Now, secant is 1 over cos. Secant squared would be 1 over cos squared. If, and I'll just highlight it in purple here. Does it make sense to you that if cos is 1 over secant, then 1 over secant squared would be cos squared? So I've changed that side to cos, but on my other side I have sine. Things aren't matching yet. Okay? What could I do with the left? Well, I guess I would FOIL it out. Multiply everything out. Maybe you notice it as a difference of squares factor. That is going to come up a lot. Differences of squares, both to factor them and when they're in their factored form. So if I multiply this out, I'm going to get 1 minus sine squared z. Okay. So they're not the same yet. And I'm going to write this in purple in a box here, because this is, well, in this box. Maybe I'll write it in purple on this side in a box. This is not part of my proof, but there is an identity that's going to help us here. Do you know which identity that's going to be? We know this. And in identities, if you know something, mental and math-wise, can you see that you could get 1 minus sine squared theta if you just moved it over to the other side? If I move the sine squared theta over to the other side, if I had this on the other side, what would be left on the left-hand side? Cos squared. Can you see you could have done the same thing and got sine squared by itself and had 1 minus cos squared theta. Because you can do that in only one mental math step. Can you see I could get 1 minus sine squared theta by just doing one mental math step of moving sine squared over to the other side? It is allowed to take this and change it to cos squared z. If you can do one of our main rules in one mental math step, you don't have to show any work. You could just go from 1 minus sine squared z to cos squared z. Then they match up, so we could write our statement. Left side equals right side. And our proof is done. But only one mental math step. Multiple mental math steps not allowed. In other words, you couldn't just be like, oh, here's the proof. I did a bunch of mental math. 1 over secant squared, I'm done. You can't just write the other side of the proof and say, I did it. Look, they match up. If you did more than one mental math step in your head. Actually happened once. I was marking a provincial fine. And it was a very complicated proof. And the student wrote, ladies and gentlemen, it is obvious that 1 plus sine theta times 1 minus sine theta equals 1 over secant squared theta. No work needs to be shown. Left side equals right side, QED. Thank you very much. They got 0, unfortunately. They didn't show any work. They just wanted to pretend that, yep, I did it all in my head. Well, that's wonderful. You can do lots of things in your head. I appreciate that. But for these, we have to show our work. The only thing you're allowed to do is if you can have something like sine squared plus cos squared equals 1, right? I can change that to these in one mental math step. But I wouldn't be allowed to do this. Okay? Here, I'll write it in red. Is the following true? Yes or no? Is that true? Is negative cos squared equal to sine squared theta minus 1? Yeah, it's true. How did I do it? Did you see that I moved the 1 to this side and the cos squared to that side? 2 mental math steps. So you would lose a mark if you decided to do that without showing work. Because it involved 2 little mental math things. You had to draw a limit somewhere. The limit is, you can do 1 mental math thing, perfect. You have to do multiple mental math things to switch it. Chances are you're going to lose a half a mark. So, the important things, because we're going to be able now, I think, to do up to about 24. You can do the first 24. Format-wise, rewrite out the question. Draw the line. Change things to sine and cos. And see if you can get it to match up left side and right side.